Hello everyone, welcome to our today's class. Today I will be discussing matrices. Matrices is the topic of the day, matrices. And my name is Dr. Joshua Aura. I teach quantitative analysis at RCM College, which publishes books like this. RCM College that publishes books like this, which go for 1,000 shillings. And if you would want to acquire them, of course, you need to give us a call. And our numbers are, as usual, these are our numbers: 0719 525 1000, 0719 525 525 525 1000, like that. Now, a matrix, ladies and gentlemen, a matrix is a rectangular array or arrangement. A rectangular array or arrangement of numbers enclosed in a pair of brackets. So a matrix is a rectangular array of numbers enclosed in a pair of brackets. Ladies and gentlemen, if you have got this kind of, for instance, a matrix here, A, say 5, 2, 3, 8, like that. So you'll be able to see straight away that this is a matrix. So you can see this matrix has got what here, rows versus what here, columns. And at the end of the day, the numbers are enclosed in a pair of what here, brackets. For CPA Section 4 quantitative analysis, what are we supposed to be knowing about matrices? We're supposed to be knowing about what we call matrix algebra. So matrix algebra, we have the concept of addition. We have to know this, addition. We have subtraction. We have multiplication. And then lastly, we have what we call matrix inversion. So these are the four operators. We have the addition and subtraction. We have multiplication. We have what inversion. We shall combine the two because they normally follow the same rules. So right there for us, addition and the subtraction. So title, addition and subtraction of two matrices. Ladies and gentlemen, we'll straight away dive into an illustration. If you're given like 3, 8, 4, 6, a matrix like this, and then you're told to add this matrix here to -1, 6, -5, 7. So for matrix addition, what you're supposed to know, ladies and gentlemen, for compatibility, for these matrices here to be compatible, they must be of the same size. They must be of the same order. They must be of the same size. They must be of the same order. So what we have here, we have like when adding, we'll take the first elements, your corresponding elements, you combine them. There is nothing much about matrix addition, matrix subtraction. So we have here 3 plus -1. That gives me 2. We have 8 plus 6. 8 is the second one here. 6 is the second one there. So 8 plus 6, that gives us 14. We have here 4 plus -5. 4 plus -5, that gives me -1. We have 6 plus 7. 6 plus 7, that gives me 13. And that is it as regards what here, matrix addition. The two matrices to be added, they must be of the same order. And then, of course, whenever you're adding them up, they have to be corresponding. You normally add corresponding elements. We normally add corresponding elements. Ladies and gentlemen, how about this illustration number 2? What if you're given 6, 8, 7, 7, 9, and then you are told you to subtract here. We have -1, 7, -3, for example, and then we have 4 there. So if you're given these two matrices here to subtract, please look at these. Just like we did for the case of addition, we'll need these two matrices here to be compatible for addition. They must be compatible for addition. So compatible for addition means that the two matrices here must be of the same order. we have 2 rows, 2 columns. 2 rows, 2 columns. So you can see that these 2 matrices are of the same size. And just like we did for addition, for subtraction, we will also subtract corresponding elements. So we have here 6 minus 1. Check this. 6 minus 1. So that gives us 7. We have 8 minus 7. That gives us 1. We have 7 minus 3. That gives us 10. We have 9 minus 4, which gives us what, somebody there? 5. And that is it. Matrix subtraction is over. So for matrix addition and subtraction, we've said the compatibility test is all about the 2 matrices being of the same size. It's all about the 2 matrices being of the same size. The 2 matrices being of the same size. The 2 matrices being of the same size. Now, ladies and gentlemen, here we are. We go to matrix multiplication. Let's go to matrix multiplication. How do we multiply matrices? First of all, we'll have to look at the scalar. The scalar multiplication. The scalar multiplication, a scalar is a real number. A scalar is a real number. So for instance, if you are told you to multiply 5 with this matrix here, 6, 5, 2, for example, 4. If someone tells you to take this matrix here, you multiply it with what here? With a 5. What are you going to get, ladies and gentlemen, at the end of the day? So each of the numbers that we have here, ladies and gentlemen, has to be multiplied with a scalar. So you simply distribute the scalar inside here. So you distribute the scalar inside here and ensure that the scalar will multiply each and every element of the matrix. So we have here like 5 times 6, that gives us 30. We have 5 times 5, that gives us 25. We have 5 times 2, that gives us what, somebody there? 10. We have 5 times 4, that gives us what, somebody there? That gives us 20, like that. That gives us 20, like that. And that is it, ladies and gentlemen. That is it, ladies and gentlemen. Scalar multiplication. The second bit of this matrix multiplication, ladies and gentlemen, is what we call now, that's B, multiplication of 2 matrices. Multiplication of 2 matrices. So if you're given, for instance, here 2, 3, 6, 4, 5, 7, and then somebody tells you to come and multiply this with, we have here 6, 4, negative 1, 5, 3, 2, for example. If somebody gives me these 2 matrices here to multiply them, how will I be able to multiply these matrices? So to multiply these matrices, the first thing that we've got to do is to assess these matrices here for compatibility. We'll come and assess these matrices here for compatibility. How do we do that? Remember, compatibility assessment, you must first of all give us the orders of the matrices. So come and define their orders. So orders, we normally talk of Roman times what here? Catholic. Orders, we normally talk of Roman times Catholic. Roman times Catholic. Roman times Catholic for R for rows, C for columns. So columns normally stand upright like this. Columns are normally vertical. So the others are the ones in this case here which are rows. So we have how many rows here? We have 2 rows. By how many columns here? Somebody 3 columns. So here we have 1, 2, 3 rows. 3 rows with how many columns? 2 columns. So ladies and gentlemen, these 2 matrices are compatible because those 2 inner values are the same. The 2 inner values are what here the same. So we have these 3 and 3. So the 2 values, inner values are the same, and therefore you'll do just on top there, you write the word compatible. So this is compatible. And if the 2 matrices are compatible, now we can go ahead and multiply the 2 matrices. And how will we multiply these 2 matrices? Remember again, matrix multiplication, we normally talk of row times column. Roman Catholic. Row times column. So the row of the first matrix will be multiplied by the columns of what here somebody? The second matrix. So the rows of the first matrix will be multiplied by the columns of the second matrix. Ladies and gentlemen, how do we do this? Remember, like in high school, we used to say, we run down the ditch. You run down the ditch. So a row multiplies a column. And how do we do this? We'll take the first element multiplied. So the first element here in this row and this column have to be multiplied together. Then we have the second elements multiplied. And then we have now the third ones being combined there. So it's running down the ditch, but you're running down the ditch in a way that shows that you guys are wise. In a way that shows that you guys are wise, because it is first ones multiplied by second ones, multiplied by third ones, multiplied by third ones. So ladies and gentlemen, what will we have here at the end of the day? What we shall have here at the end of the day, ladies and gentlemen, what we shall have here at the end of the day, ladies and gentlemen, if you have your calculator, we are saying it's Roman Catholic. Row 1, column 1. So first element here we have 2 times 6. And then of course the elements must be added there. So plus the second ones. So second ones are 3 and 4. So we have here plus 3 times 4. Plus we have the third ones, 6 times minus 1. 6 times minus 1, what do we have there? Once you combine, you will end up getting 18. You'll end up getting 18. From there, this row to be multiplied with the second column. This row with the second column. So how do we do it? First ones, these are 2 and 5. Second ones are 3 and 3. Third ones are 6 and what here? 6 and 2. So this row has to multiply the first column, and we were able to get 18, and we will extend the same with the second column. So with the second column, ladies and gentlemen, what do we have there? So we have the first ones multiplied. So we have 2 by 5. Plus the second ones multiplied. So we have 3 by 3. Plus the third ones multiplied, the 6 by what here? 6 by 2, so plus 6 by 2. Which at the end of the day will give us what here? Which at the end of the day will give us 31. 31. Now, ladies and gentlemen, from there we have this row. This row with the columns of the second matrix. So this row will be multiplied with the columns of the second matrix. And how do we do this? It is the concept of running down the ditch. But as I run down the ditch, I must always know the steps to step on. So we have here, we're running down the ditch, but remember it is first ones multiplied, plus my second step here, plus my third step. So we have, ladies and gentlemen, if I was to put my calculator on here, what do we have? First ones are 4 and 6. Please always remember to add them, plus 5 and 4, second ones, 5 and 4, plus the third ones, which will be plus 7 times minus 1, times minus 1, times minus 1. So, ladies and gentlemen, I'm getting here 30 what here? I am getting 37. 37. So from there, come and take on this row and the second column using the same criteria. Using the same criteria, we have the first ones, which will be 4 by 5. 4 by 5. The second ones will be 5 and 3. So plus 5 by 3. 5 by 3 plus 7. 7 by 2. 7 by 2. So plus 7 by 2. Which at the end of the day, ladies and gentlemen, will give me what here? 49. Which will come and give me 49. Which will come and give me 49. Now, ladies and gentlemen, that is all as regards to what here? Multiplication of matrices. As regards to multiplication of matrices, what am I supposed to know? The compatibility assessment. And then number 2, how do we navigate this concept of Roman Catholic? Rows of the first matrix being multiplied by the columns of the second matrix, the columns of the second matrix, the columns of the second matrix, columns of the second matrix. Matrix multiplication. Now, ladies and gentlemen, that now takes me to the last, area of matrices as pertains to what? As pertains to matrix algebra. What basically we are calling inversion. So for inversion, what are we supposed to know, my friends? That inversion is only applicable for square matrices. So it is a square matrix. It's a square matrix operator. It's a square matrix operation. So square matrices, if you look at your syllabus very well, we are only required to know how to inverse 2 by 2 matrices and 3 by 3 matrices. So square matrix operation, we start with the 2 by 2 matrix. 2 by 2 matrix. So ladies and gentlemen, 2 by 2, if we are given here A equals 3, 8, we have here 2, 6 like that. So if we are given this matrix A, 3, 8, 2, and 6. You can see these has got how many rows? 2 rows. With how many columns? 2. So it's a square matrix. And if it's a square matrix, then we can very easily inverse it. So they want us to give them the inverse of A. So inverse of A, that is like that. A raised to minus 1. That is the symbol of inverse of A. So solution, my great friend, solution here, for us to be able to get the inverse of this matrix, the first thing that we shall do is to ascertain, the determinant. So ascertain the determinant of A, which is abbreviated like this. The first thing that you do is to ascertain the determinant of A. So come and they give us the determinant of A, which will be equal to PPD minus PSD. So determinant of A is product of primary diagonal minus product of secondary diagonal. So product of primary diagonal minus product of secondary diagonal. Remember your diagonals, ladies and gentlemen. We have this being a diagonal, and then the other one is what here. And what I was told when I was learning these things, that this diagonal will start from the first element. The diagonal that starts from the first element is our primary. From the first element of, when you're writing this matrix, even if you're left-handed, I want to believe we start writing this with 3. So 3 is the first element of the matrix, and that matrix, or rather that diagonal which strikes, which comes from the first element of the matrix, is what we are calling the primary. And then the other one is the secondary. So they want us to give them product of the primary. So product of the primary, this will be 3 times what here? 3 times 6. 3 times 6 minus product of the secondary. So product of the secondary, what do we have there? 2 times what here, somebody? 2 times 8. Product means you multiply. So anytime we talk about determinant of a matrix A, determinant equals product of primary diagonal minus product of secondary diagonal. So we have here 3 times 6, which is 18, minus 2 times 8, which is what here, 16. So then this gives us a determinant of 2. 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 So you ascertain the determinant of A, and this is how we get the determinant of A. Having gotten the determinant of A, ladies and gentlemen, now we'll be able to engage the second gear. The second gear, which is the second step of inversion, is to define the inverse. So go ahead and define the inverse. Go ahead and define the inverse. Go ahead and define the inverse. So inverse definition, inverse definition. Inverse definition, what do we have here? We have A raised to minus 1. Inverse definition, we have A raised to minus 1. This is a symbol of our inverse. Ladies and gentlemen, for inversion purposes, we shall take 1 over the determinant, 1 over the determinant, into, we enter inside the brackets here, and we shall do some algorithm here. We shall do some function here. Inside the brackets, what we shall do is to exchange, you exchange primary elements. You exchange primary elements. And then, ladies and gentlemen, you change signs of secondary elements. You change signs of secondary, you change signs of secondary elements. You change signs of secondary elements. So then if that is the case, then our A raised to minus 1 will be equal to 1 over the determinant. Will be equal to 1 over the determinant that we got up there as 2. 1 over 2 into, what have we said about the primary elements? The primary elements, we shall swap them. The primary elements are normally swapped. The primary elements are normally swapped. So we have 6 and 3, we interchange them. So we have here 6 versus 3. 6 versus 3. How about the secondary elements? Secondary elements, we shall leave them where they are intercally, but we are needed to change their signs. We are needed to change their signs. So here we have minus 8 versus what here? Somebody minus 2 like that. So we change their signs. we change the signs of what here? The secondary elements. And that is the end of this. Don't try to distribute this inside there. Don't try to distribute this inside there. Don't try to distribute that inside there. So inverse definition like that. So perhaps what I could do for the interest of all of us understanding this concept very well is to look at another example. So please allow Mwalimu here to look at another example. So if you're given another matrix, for example, matrix A here, which is 2, -1, we have here 6, -3. If you're given this kind of a matrix and then we are required, to determine the inverse of A. We determine the inverse of A. So how would we be able to determine the inverse of a solution? Ladies and gentlemen, as usual, give us the determinant. So how do we ascertain the determinant? Determinant is product of primary diagonal minus product of secondary diagonal. I'm repeating this, ladies and gentlemen. This is product of primary diagonal minus product of secondary diagonal. So the product of the primary diagonal is here. The primary diagonal is here. So product means that I multiply the 2. So then this will be 2 times -3. 2 times -3, right? Minus product of secondary, which will be 6 times -1. So we have primary is 2, ladies and gentlemen, times what here? -3. 2 times -3. 2 times -3. 2 times -3. And then we have, ladies and gentlemen, 6 times minus what here? -1. So then, ladies and gentlemen, we have here 2 times -3. 2 times -3 gives me minus what here? -6. So we have here, ladies and gentlemen, minus 6 times -1 will give me, 6 times -1 will give me minus what here? -6. So -6 minus -6, this will be -6 plus 6. Which will give me a determinant of what here? 0, and that means that we have to stop where? We have to stop here simply because any matrix that does not have a determinant, any matrix which, ladies and gentlemen, whose determinant is 0, doesn't have an inverse. A matrix which doesn't have an inverse because it has got a determinant of 0 is called a singular matrix. It's called a singular matrix. So in this case here, this is a singular matrix. We shall stop inversing it at that particular point. So then allow me to take you through another full example. Where they have given us, ladies and gentlemen, matrix A. Matrix A with the following. So we have here 2, for example, 9, -3, ladies and gentlemen, -3. Vis-a-vis what here? -5. If somebody gives us this kind of a matrix and he wants us to ascertain the inverse, what we shall do, solution, the first thing we shall do is to define the determinant. We define the determinant. So how do we define the determinant? So determinant is product of primary. So this is the primary, this is the secondary. So primary, what do we have here? We have 2 times -5 product minus product of secondary, which will be -3 times 9. So ladies and gentlemen, this will be 2 times -5 is -10, minus into brackets here, -3 and 9. -3 and 9 gives me -27. So then we have here -10 plus 27 because of the 2 minuses. So -10 plus 27, this will give us what figure? Somebody here, this will give us 17. This will give us 17. So once I have this as my determinant, my great friends, the next thing that I will do is to come and define the inverse. So come and define the inverse for us. Define the inverse for us. So go ahead and define the inverse for us. Come and define the inverse for us. So how will we be able to get the inverse, ladies and gentlemen? A inverse will be equal to 1 over the determinant that we have found there as 17 into, ladies and gentlemen, we have the concept of exchanging the primaries. Exchanging the primaries, we have here -5 taking the position of this and the 2 going down there. And then the secondary will leave the secondary where they are, but change their signs. We leave the secondaries where they are, but we change their signs. So here we'll talk of -9. Initially it was positive. This one here, which was -3, now becomes positive what there? +3. This is the inverse of matrix A. This is the inverse of matrix A. 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 So I hope that is agreeable. I hope that is okay, ladies and gentlemen. And if that is the case, I would beg to go to the next thing, which is inversing, ladies and gentlemen, a 3 by 3 matrix. So inversion of a 3 by 3 matrix. How do we inverse a 3 by 3 matrix? Remember, we say that inversion is a process of what? It's a process of square matrices. And our syllabus needs us to know how to inverse a 2 by 2 matrix and a 3 by 3 matrix. So come and give us here A. A, for example, -3, 2, 1. We have 4, for example, -1, 3. We have 2, 8, for example, 6. So if we are given this kind of a matrix, and then we are required here to do something very easy, we are required to determine the inverse. We are required here to determine the inverse. So for us to get the inverse solution, the first thing that we shall do is to come, ladies and gentlemen, and get the determinant. Remember here, there are basically 4 steps. There are basically 4 steps. Step number 1, you ascertain the determinant. Step number 2, you give us the minor elements. Step number 2, you give us the minor elements. Step number 3, you give us the cofactors. The cofactors. Step number 4, ladies and gentlemen, now you define the inverse. Step number 4, you define what here? You define the inverse. So anytime you are given a matrix that has got 3 rows vis-a-vis 3 columns, this is how we shall be getting the inverse of a 3 by 3 matrix. So number 1, you give us the determinant. Number 2, you give us the minor elements. Number 3, you give us the cofactors. Number 4, you define the inverse. Number 4, you define the inverse. So let's start with the determinant. We shall look at we shall look at each of these steps one at a time. So we start with the determinant. We start with the determinant. We start with the determinant, ladies and gentlemen. Determinant here, determinant. There are very, very many ways that you could make use of to ascertain the determinant. But the very best way will be, you will come and write this matrix. You write this matrix the way it is. The way it is. You rewrite it, you rewrite it. You rewrite the matrix the way it is, like that. And for determinant ascertainment purposes, you will come and duplicate the first 2 columns besides the major matrix. So you duplicate the first 2 columns. So we have here -3 is column number 1. So you write the first 2 columns besides the main one. And then now the second column will be 2 - 1 versus 8, ladies and gentlemen. And if that is the case, then you will come and give us this primary. And in this particular case, we shall have 3 primary diagonals. The one that in this case here starts from the first element running through 3 values. So we have, this is the first one. We have the second one like that. We have the third one like that. So we have what we call the PPD, product of primary diagonal. Product of primary diagonal. What we shall do for product of primary diagonal, product means you multiply. So we have here -3 times -1 times 6 plus the secondary diagonal, which will be 2 times 3. We multiply the elements. 2 times 3 times 2 plus we have here 1 times 4. 1 times 4 times 8. I hope my cameraman will be able to see me all the way up to there. Okay, so now get hold of your calculator. Hold of our calculator. We have what we have there. We have -3. So we have -3 times -1 times 6 plus the second one now, which is 2 by 3 by 2 plus 1 by 4 by 8. 1 by 4 by 8, this one here gives me 60 what here? 62. And then come and give us the product of the secondary diagonal. So secondary diagonal, now we have the secondary diagonal moving from here. So we have the first one like that. We have the other one which will be cutting across 3 elements. We have in this case here the third one. For 3 by 3, we have got 3 secondary diagonals. So come and pick the first one, which will be 2 times minus 1, 2 times minus 1 times 1 plus 8 times 3 times minus 3. 8 times 3 times minus 3. Plus, ladies and gentlemen, we have 6 times 4 times 2. Give us an answer. So, ladies and gentlemen, what we have here at the end of the day, we'll talk of 2 times minus 1 times 1. 2 times minus 1 times 1 plus 8 by 3. 8 by 3 by negative 3. 8 by 3 by negative 3 plus 6 by 4 by 2. What figure are we getting? We are getting negative 26. Negative 26. Now, ladies and gentlemen, please don't forget where we are going and where we are coming from. What they wanted us to do is to come and give them the determinant of A, which is PPD minus PSD. The PPD is 62 minus the PSD, which is minus 26. So in short, we have that one being 88. 88 because minus minus, of course, that will give me what here positive. So the determinant is 88. Determinant, I will have to store this thing somewhere. Determinant is 88. Now, once I have the determinant of 88, now I can go to the second step, which is the step of minor elements. Go to the second step, which is the step of what here? Minor elements. Step of minor elements. So come and give us, ladies and gentlemen, the minor elements. Give us the minor elements. It will be very important for us to know what minor elements are. Ladies and gentlemen, minor elements, basically a minor element, I want you to understand this, that a minor element is a determinant, or is the determinant. Is the determinant of the submatrix, determinant of the submatrix that is left after covering or ignoring it, after covering the row and the column. The row and the column that defines a specific value of a matrix, a specific value of what here, somebody? A matrix. So a minor element happens to be the determinant. Again, we are encountering this thing of determinant here. Happens to be the determinant of the submatrix that is left after covering the row stroke column that defines a specific value of a matrix. A specific value of a matrix. Having understood this particular simple definition of a minor element, now getting minor elements for all the other matrix elements is not really a hard nut to crack. No. These are things I'll be able to get now very fast. So we start with, this is our major matrix here. It is minus 3, 2, 1. We have 4 minus 1, 3. We have 2, 8, 6, like that. So once I have this matrix and you want me to find its minor, everything becomes very easy. Everything becomes very easy. M stands for minor. So if they want me to give them, the minor element of this negative 3, the minor element of this negative, the first value is negative 3. If they want me to give them the minor element of this negative 3 value, what I will do is to hide it. Remember, it is a hide and seek. What we shall do, ladies and gentlemen, is to hide the element row-wise, and then you hide it column-wise. You hide the element row-wise and the column-wise. And then, of course, the moment you do that, you'll be left with some sub-matrix, part of the bigger matrix. And this matrix, what we shall do with it, ladies and gentlemen, is to ascertain its determinant. So go ahead and give us the determinant here. Remember, determinant is product of primary. So this will be minus 1 times 6 minus the secondary. So I have my calculator here. Product of primary will be, ladies and gentlemen, product of primary will be minus 1 times 6 minus secondary. And for secondary, I must always open brackets for secondary. So for secondary, we have here 8 by 3. Always open brackets for secondary. So then, ladies and gentlemen, what will I have at the end of the day? The minor of this is negative 30. Now, if you wish, before you get used to, you can keep on writing this matrix as many times as possible. So like now we have here A is minus 3, 2, 1. We have 4 minus 1, 3. We have 2, 8 vis-a-vis 6. If they want me to give them the minor element of this second value, what will I do? I will hide it row-wise. And then I hide it column-wise. So the value whose minor element you are after, you must hide it row-wise and column-wise. And the moment you do that, you will be left with what we are calling a sub-matrix for elements. So that sub-matrix, what do you do with it? The sub-matrix, ladies and gentlemen, we'll talk of 4 times what here? 4 times 6 minus 2 times 3. 2 times 3. 4 times 6 minus 2 times 3, which will give us at the end of the day 18. Which will give us 18. Now, you don't have to get 9 minor elements. If they want me to give them the minor element of this, ladies and gentlemen, what I need to do is to hide this figure. They hide it row-wise. You hide it row-wise and column-wise. And I should be able to do that exercise without really drawing up anything here. I should be able to figure out the sub-matrix left. So like now here, if you I'm now on the third value. If you tell me to ascertain the minor element of this third value, I'll hide it row-wise and column-wise. And if I do that, I'll be able to see the primary diagonal left out. Primary diagonal of the sub, because I will see this is up there, this is up there. So the primary left out is 408. So I'll come and say 4 times 8. So 4 times 8. We have here minus, open brackets for, if this is the primary, the secondary will be this. Open brackets, therefore, the secondary. So secondary we have here 2 times 1. Okay, so I'm seeing here 31 here, 34 like that. So you proceed like that until you finish up everything. So now I'm on my fourth one. On my fourth one, ladies and gentlemen, what will I do? On my fourth figure, I'll hide it row-wise and column-wise. When I hide it row-wise and column-wise, I'm able to see the primary that are left uncurved. The primary which are left uncurved, that will be 2 times 6. So we have here 2 times 6 minus, if these are my primary, then the perfect match rule tells me that 8 and 1 will be my secondary. So minus 8 like that, which gives me 4, exactly. Go to the fifth value. The fifth value, you hide it row-wise and column-wise. Hide it row-wise and column-wise, and then identify the primaries which are uncovered. The primaries are uncovered here minus 3 and 6. So we have here minus 3. We have here minus 3. So minus 3 by 6. By 6. Minus, ladies and gentlemen, if these are my primary, then my secondaries are there. So minus the secondary there, which is 2 times 1, which will give me minus 20. Minus 20. So you continue like that to go to this figure here. How do we do it? We hide the figure. Remember, it is about hiding the figure. You hide the figure row-wise and column-wise. So row-wise, we have this and this. So we have this and this being hidden, this and this being hidden, and then now we are left with minus 3. If you have hidden this and this, we'll be left here with minus 3. We'll be left here with minus 3 by 8, minus 3 by 8, minus 3 by 8, minus 2 times 2. So what figure do I have here? Minus 28. go to this figure. It's all about hiding the figure. So you hide it row-wise and column-wise. Row-wise and column-wise. What do we have there? We have 6. Which will give us what figure somewhere there? 7. Because once I add this and this, I'll be left with this primary. So 2 times 3 minus open brackets always for secondary, which is minus 1 and what here? 7. So please go to this. So I shall hide this one like that. So once I hide like that, I'm able to see the primaries which are left uncovered. So this one hidden like that, the primary left uncovered. What do we have there, somebody? We have minus 3 by 3. Minus 3 by 3. These are the primary. Then the secondary will be like that. So minus open brackets always for secondary. So what figure am I able to see there? Minus 13. The last one, ladies and gentlemen, is this, which will be hidden row-wise and column-wise, and I'm able to see my primary. So we have here 3 minus 8, which will give me minus what here? Minus 5. Ladies and gentlemen, I've been able to come up with my primary, or rather my minor elements. The moment I come up with my minor elements, the next thing that I need to do is to go to the step of cofactors. So go to the step of cofactors. Go to the step of cofactors. Go to the step of cofactors. So what do we have here as our cofactors? For us to be able to get cofactors, the easiest way for you to remember these is to recall the diamond rule. The diamond rule. So please come and put the diamond on your minor elements. The diamond normally touches the central elements of external rows and columns. So from 4, we'll go to 18. The central. So 4, 18, negative 28, negative 13, and then there we are, like that. Meaning that all the figures that have been touched with the diamond will have all their signs, ladies and gentlemen, changing. The figures that have been touched by my prestigious diamond will have all their figures doing what you're changing. So my cofactors then will be equal to, we have here minus 30. This gives me minus 18 because initially hitherto it was positive, but now because of the concept of the corner of the diamond touching it, the sign must change. So we have here minus 18. Then we have, ladies and gentlemen, 34. Of course, this has a corner, so we have here minus what here? Minus 4. This will remain because it doesn't have a corner. So minus 20, minus 20, minus 20. Then we have here 28. Then we have 28. So come here, we have 7. This gives us positive what here? 13. This gives us negative what, ladies and gentlemen? Negative 5. So ladies and gentlemen, these are the cofactors. These are the cofactors. Now, once I get the cofactors, the next thing, ladies and gentlemen, will be for us, to define the universe. The last thing now is universe definition. Universe definition. How do we define our universe, ladies and gentlemen? Our universe here will be A universe will be equal to 1 over the determinant into the cofactors transposed into the cofactors down what here? Transposed. So to get the universe of A for a 3 by 3, you will take here 1 over the determinant, which was 88 if you can recall. We got this 88 somewhere there. We got 88 somewhere there. Into the cofactors transposed. How do you transpose the cofactors? To transpose a matrix means changing rows to become columns, such that row 1 becomes column 1. Row 1 becomes column 1. So we have row 1 moving down, we have minus 30, minus 18, we have 34. And then we have row 2 becomes column 2. So here we have minus 4, minus 20, and 28. And then we have row 3 becoming column 3. So we have 7, we have 13, and then we have minus 5. And ladies and gentlemen, that now marks the end of this particular question and the end of our today's class. Please don't forget RCM's books. These revision kits, we have both study text and revision kits going at a very low price. And also don't forget that we have online classes where we shall give you access to all our pre-recorded videos, access to all our pre-recorded videos at a price of Kenya shillings 3,000. Only you get access to all videos of the entire syllabus for 3,000. And what's good, what's more important, that with these 3,000, you'll also be getting live access to our live Zoom classes, and then of course access to our block revision. Thank you, and thank you very much. God bless you.